Okay, part 4, questions 35 and 36. So we have a straightforward proof in a coordinate plane. First, we got to prove that PQRS is a rhombus, and then we have to prove that PQRS is not a square. All right, let's get to it. So for me, it's easier to just find the slopes of the four sides and the slopes of the diagonals and work off of that. So that's what I'm going to do. So I'm going to go ahead and find the slope of PQ. So the slope of PQ, it goes up 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. So the slope of PQ is actually 1 over 1, or just 1. The slope of SR, 1, 2, 3, 4, 5 over 5, it's the same thing, okay? It's 1 over 1, or just 1. The slope of PR, the slope of PS, let's see, it goes down 1, 1, 2, 3, 4, 5, 6, 7 over 1. So the slope of PS is -7. The slope of QR is the same, -7. So this information right over here, this actually proves that it is a parallelogram, which is actually what I need to do first, the way I'm working out this proof. Okay, so this proves it's a parallelogram because the opposite sides are parallel. Now, to prove it's a rhombus, I need the slopes of the diagonals. So let's go ahead and find the slope of PR. So what's the slope of PR? Well, let's see, it goes down 1, 2, goes down 2 over 1, 2, 3, 4, 5, 6. So it goes down 2 over 6, which reduces to -1/3. Now the slope of SQ. I want the slope of SQ to be 3 over 1. Okay, why do I want it to be 3 over 1? I want it to be 3 over 1 because in a rhombus, the slopes of the diagonals are negative reciprocals since the diagonals are perpendicular. So let's see if that's the case. So it goes up from S, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then over 1, 2, 3, 4. So it goes up 12 over 4, which is 3 over 1. So then here's what I write. PQRS is a rhombus because it's a parallelogram with perpendicular diagonals. So this information here, this is telling you the diagonals are perpendicular. All right? So here's what I did to prove it's a rhombus. I proved that it's a parallelogram with perpendicular diagonals. Now, why is it not a square? So the reason it's not a square, and I don't need to do any much further work except to write a statement. PQRS is not a square since the connecting sides are not perpendicular. So if you look at the slopes of the connecting sides, for example, SR, let me get a highlighter to highlight that. So if you look at the line segment SR and the line segment PS, look at the slopes of SR and look at the slope of PS. They are not negative reciprocals, which means this is not 90 degrees, which means it is not a square. All right, so that's 35. It's actually pretty straightforward for a 6-point question. Okay, so for this last problem, we got Freda, who detects an airplane that's flying at a constant speed, and it's flying over her head in a straight line in this direction, or the other direction, depending on how you drew it. But the important piece here, it's actually two important pieces. The first is that she sees the airplane at an angle of elevation of 15 degrees. So what that means is that the angle between her line of sight and the airplane is 15 degrees. So this is 15 degrees. Now, if you're struggling with that, how I got that 15 degrees, I have a whole video dedicated to angles of elevation and angles of depression. So that angle of elevation is 15 degrees. And then the other important piece, remember I said there's two important pieces here, is that the airplane is flying at an altitude, so its distance from the ground is 6,250. Okay, and this is a right triangle. So what I actually want to do first is I want to find this distance here from the airplane to this point in the air, because I'm looking for the horizontal distance the airplane traveled. So in order to find that, I can set up an equation. I can set up tan of 15 degrees equals the opposite over the adjacent. And then you can cross multiply to solve for x. You put that over 1, cross multiply. X will be equal to 6,250 divided by the tan of 15. So you get yourself your calculator and input that into the calculator. So it's 6,250 divided by the tan of 15. And we get a pretty big number. What's that? 23,000. Why won't you stay there? 23,325. If we round it to the nearest foot. 23,325. Okay, great. Now, 1 minute later, so we got this scenario when it first starts off. And then we have another scenario for 1 minute later. So 1 minute later. 1 minute later, we have a slightly different scenario. So Fred is still on the ground, and the plane is still flying at that altitude of 6,250. But the airplane is now closer to Freda. So the airplane is now closer to her, and the angle of elevation, because the airplane is closer to her, the angle of elevation has now increased to 52 degrees. So now I'm actually interested in figuring out this distance here. So you know that I'm going to do something similar, right? I'm going to do y equals, and it's going to be 6,250 divided by the tan of 52 degrees. So I did skip some steps there, but you can write this, the equation. You can say the tan of 52 equals 6,250 over y, cross multiply, and you'll work out to this. So I got 6,250 divided by the tan of 52. And I get 4,883. So the distance for y is 4,883. That's what y equals. All right, now let me break this down a little bit more so you can see what's happened. So I'm going to make a separate diagram here for you, just to sort of teach you this in a better way. So here's the scenario we start off with. Okay, you got an airplane. That's an airplane. And the airplane's flying towards Freda. But the airplane's flying horizontally. Initially, the distance from the airplane to this point, we found that to be, that was that first number we calculated. Remember what it was? It was 23,325. 1 minute later, the airplane gets closer to her, right? So the airplane is now here. Okay, that's the airplane. So the airplane is now here 1 minute later, and it's the distance between the airplane and this point has now shortened to what? It is 4,883. Use red for that, just to be consistent. 4,883 feet. What they're asking is, if you read the question, I know we didn't read it, but if you read it, they're asking for how far the plane has traveled. They're asking for this distance. So if you want this distance, you need to subtract 4,883 from 23,325. So if you want that answer, you need to do 23,325. I'm going to put it here because I don't have any more space up there. Minus 4,883. And what's that equal to? Let's get a calculator. 23,325 minus 4,883. I get 18,442 feet. 18,442 feet. 18,442 feet. So that's the answer to the first question. That's how far the plane has traveled, right? That's this distance here. It's 18,442 feet. Now, what's the speed of the airplane? I don't know why they're asking this in a geometry test, but they are. Speed is distance divided by time. So if the airplane's traveled 18,442 feet in 1 minute, that's the speed in feet per minute. They don't want feet per minute. They want miles per hour. So let's convert this to, let's do miles per minute first. So if I multiply this by 1, so in case you didn't know this, you can find this in the back of your test. They give you this. They tell you that 1 mile is equivalent to 5,280 feet. So when I multiply by this, you'll see that the feet cancel and I'm left with miles per minute. So I get 18,442 miles per 5,280 minutes. If you divide that, you get approximately 3.49 miles per minute. So that's how much miles it does per minute, but they want miles per hour. Well, there are 60 minutes in 1 hour, so all I need to do is just multiply this by 60 and I get my final answer. So let's just multiply that by 60. My final answer is approximately 210 miles per hour. It actually works out to approximately 209.56, but it says to round to the nearest mile per hour. So we round to the nearest whole number. So the final answer is 210 miles per hour. So the tough part, I guess, for some students is the conversion. So first I convert it to miles per minute, and then I just multiplied by 60 to get it into miles per hour. All right, I hope this helps. Take care.